All right.
I understand these ranges. I swear, I don't know how you could go.
It would hurt the download.
I don't know how it would. The only way I can see is if it went like this.
End of this needs to be
Mr. Pettis, what's it called?
We only started looking at it after I let it go.
Velocity starts positive.
So the initial velocity value is here.
So yeah, okay.
Yeah. It's negative and
Oh, the position value? No.
same.
Yeah, that's what I did, but we
It's 0.
And then it goes down, and then it goes back up.
All in here.
But the goes down here.
All right, are we close enough here?
I'm just gonna
there's a couple ways to do this. You're going to figure it out. All right. The whole thing about this is you're just trying to figure it out. Okay? It's not necessarily obvious. So we know it starts at 0 position. All right. Is it moving fast or moving slow? All right. We start looking at it after I let it go. It's fast, which means it's going to be steep, but it's slowing down. True?
yes.
Okay. So we know it's going to be a parabola. Now, when it gets to here, it gets on the flat part, and what happens? Okay? Now, the velocity graph, a little bit different. Velocity graph's a little different. Starts here, and it slows down until it gets to that moment, true? So, but it doesn't stop, so it doesn't ever get to the axis, it just slows down. And then goes to constant speed.
Oh,
Can you explain why the velocity started not at 0?
Yeah, because we start looking at it right after I let it go.
But didn't you push it on the first, like the one where the ramp was down?
No, I just let it. When I let it go on a ramp,
That had to hurt.
Are you okay? I like felt that in my soul.
I didn't slice my finger open.
Mr. Petta, let it hit the floor.
No, I don't want to.
I was kind of disappointed.
Yeah, hey! Oh! Wow! Wow!
Disappointed. That was
Man! Good thing I got cat-like reflexes.
It's like a Newton's
What's going on over here?
It would transfer its energy to the auto.
And then when you divide by the square.
None of that is true.
That's kind of
All right. Let me see you draw the motion maps real quick.
Mr. Paddles, what are the odds you use to like
Right.
throw
They'll like just spike the ball at the ground as hard as you can and see if it breaks the top.
Well, it's not just gonna dent it. I don't want to do
But if it's just gonna dent it, then what do we see?
that. No.
It's like destruction is like.
This is the first floor, it's not like it's gonna do anything to the people below.
Destruction is
So it starts out with acceleration.
And velocity.
Which way is the acceleration?
Yeah.
And acceleration.
But like seriously.
And they are even. I don't accelerate.
Oh, my favorite hobby is just destroying house windows.
Is this tile? Or is it?
Okay. This is a little less clear than it would normally be because
But it has like a.
I would have liked to have looked at acceleration homework one first. But I gotta be out tomorrow, so I have to speed up. So it's a little bit of
Okay, I'm gonna read
No, gentlemen and ladies, focus on me for a sec. So let's do this real fast, this motion map, and then I'll tell you what's going on. So we start here, it's moving fast and slowing down, yes? So what's happening to the spacing between them? Okay? So the spacing is getting smaller, and then what happens when it gets on this part up here? Well, it slows down, and then the spacing is small. What does that indicate about the speed? It's really slow there, yes? So do we start off with a velocity arrow on the first one this time? Yes, we do, because when we start looking at it, it's already moving. In fact, it's moving as fast as it's going to move.
Did it get shorter?
And a little less. A little less. What about these cuties?
All the same.
They are small and they are equal.
Is it equal to that last?
No, it has to be smaller than this one,
Small.
because it moved from here up to the top. So on that, it had to continue to slow down. True?
On my first time.
Now,
in this class.
is there a time that it's accelerating?
Yes.
This is an important question. Is there a time that it's accelerating?
Yes.
Up the ramp.
Okay, so the thing about this is that in your everyday language, acceleration only means speeding up. But in here, acceleration could be speeding up or slowing down. It's any change. Is there an acceleration value here?
Yes.
What do you notice about it?
Negative.
Negative. So which way do you think that acceleration arrows point?
It's just like Newton's equation because on the right side, the balls are coming, inverse line, zero line. They have a negative acceleration. It's a deceleration.
Yeah, you grab the Oh, yeah. You would accelerate the slowing down. No. Okay, you were right in the fact that Newton's cradle deals with gravity, acceleration, and
It's a double.
That's it. Everything else, yes. Well, that's something about the I was like, I remember the first time you said that, I remember what you're talking about because it was so far.
He just like,
I'm not gonna roll, when you drop the ball, the economy.
The economy, it really is.
The money goes up your. Is these fans? What?
Now,
Now we have an inflation.
before you, focus please. Before you move, let me tell you what's going on. So tomorrow I gotta take the kids to the orthodontist. Fire up for that. You guys are gonna finish acceleration homework 1 and acceleration homework 2. You have all the tools you need to do that now. Is that cool? If you happen to finish those, you can do this one. This is 3. Okay? It's also multiple pages. And they're multiple pages because I like to make the pictures big so you can draw on this. Okay? We'll be looking at this one on Thursday and Friday. Another day I have to be out. It's so funny. I've been out more this year than literally ever. It's family stuff.
It goes down.
Everyone bring your chairs forward. I want to be part of this.
People are winning that. Like, I wanted to like score.
And then Sarah brought a bunch.
This is too much work.
We are in the deployment phase.
You're in the top.
It's on the sector of the outer sector of the 93.
I actually am very predictable.
Yeah, you could.
All right.
You can't hold it higher than 90.
I feel like some of you took the transition as a tacit indication that we were somehow done. That was not
That's
a.
so true.
I completely understand. That was not a tacit indication that we were somehow done. I'm so sorry.
You are checking though.
I'm going to draw a little bit more. If I were you, I would draw along. Okay? One of the questions that you asked me, which I think is a super valid question, is if I got a ball on a ramp, I'm going to start at the top, position 0, velocity 0, I'm just going to let it roll. It's going to roll down, true? Okay? How do I know where to put the dots for the motion there?
You guess.
You don't have to guess. I mean, you could guess. I mean, you know that they're speeding up. It's speeding up, so the dots are getting farther apart. But if you don't have the position time graph, you only have a velocity time graph. How could you figure out where to put them? So, as we've seen, the velocity time graph is linear. You guys did a whole lab on this. Remember that? Is that cool? And let's say we're going to do like 4 seconds. So this is 4, and this is 2, and that'll be 3, and that'll be 1. Is that cool? Here's the question. Where on this graph does it tell me how far I went? Now, to remind you, when we were doing constant velocity, this one was diagonal, this one was horizontal, right? How do we find out on the velocity graph how far you went?
Don't you find the area?
You 100% find the area, right? When we were doing constant speed, though, this was horizontal, so they were all rectangles. But if I go to shade the area here, what shape is it going to be?
Triangle.
It's going to be a triangle. So if I go to do that, let's see what that might look like. You see that cute little triangle? So that would tell you how far it went in the first second. Does that sound okay? All right, now, here is the question. We're going to call this, one triangle. Like it's triangle number one. All right. One. How much further do you think it went after 2 seconds than 1 second? It had to go farther, right? Yeah.
Like, you square it, I don't really know.
Yeah, that's actually true. Like, if you knew how far it went and you doubled the distance, right? But let's see what it looks like graphically, because I think it's super interesting. If I drop this down at 2, is it obvious to you how much farther it went? She said it went 1.5 squares farther, which is 100% true. But watch this, because I think this thing is really cool.
Why are we doing so many triangles?
Because if your unit is a triangle, how many triangles do you have after 1 second? Just one. But how many total triangles do you have after 2 seconds?
What?
So
1, 2,
2,
4.
3, 4. So as Asher told us, you double the time, but you get 4 times the number of triangles. What if I go here?
1, 2, 3, 4, 5, 6, 7, 8, 9. I guess.
So we'll pick this up tomorrow, or Wednesday, nope, Thursday.